Hi students. In this lecture, I am going to discuss problems based on Faraday's law and motional EMF. Let us see first one. See the question given. Given conducting rod length is L and given uniform angular velocity omega about one end. Field is uniform. Direction given it is along the axis of rotation. Calculate the EMF induced between the ends of the rod. And condition is neglect any centripetal force acting on the free electrons as they move in circular paths. Let us see how to start. Say condition is that it is a uniform rod which is now rotating about its one end. A uniform rod rotation about one end. Let us take now axis is a horizontal and normal to plane of this board. Let us take this board to plane as xy plane. Then axis of rotation is along z axis. You can see here. This is now axis of rotation, which is along z axis. Let us say rotation is now like this. It is given omega constant. Suppose this is A and this is B. And the condition given that field is now along the axis. That means it may be along positive z axis or may be along negative z axis. So I'm taking here field is now along negative z axis, means into the board. Okay, normal to plane of the board, and it is into the board. So now we are going to use here the concept of motional EMF. Let us see carefully. Since the rod is rotating, each and every point follows now circular path. So here I am taking at some distance x from the axis of rotation. So I am taking at some distance x from axis of rotation an element of length dx. And you can see its velocity is now, it is r omega. Here r means x. So it is now x into omega. That is now velocity, right? And you can see this velocity is now into the board, right? Wait. Velocity is now, we are taking a rotation is above z axis. Then velocity will be along positive y axis. It is not into the board. Direction of velocity of this element, it is now along positive y axis at that instant. Okay, right. And see now across this element EMF induced, that is given by dE equal to, it is B, its length is dx, so BLV, and V value X omega. Okay, this is the EMF induced across the ends of that element. Like this, we have to take all elements from A to B. That means we have to integrate. So now take integration. Limits from x equal to 0 to, it is up to L. Now see what we get. So we can take a B and omega outside. Remaining is now x dx. Integration of x dx limits 0 to L. X dx, it is now x square by 2. Now take limits. It is now half b omega El square. This is now EMF induced across the ends of the rod. Now focus which end is at a high potential and which end is at low potential. Okay, let us see how to decide that. So I am focusing here. Force acting on electrons. F bar equal to Q into V bar cross B bar. So focusing on electrons, charge is negative. So I am taking minus here. Now see carefully. Because of rotation of the rod, velocity of that element, or you can say the electrons which are now in this element. For them, velocity is now x omega. Direction is now, it is along positive axis at that instant, right? It is along positive y-axis. So I am taking here j cap, direction of v bar, cross b bar. B bar is now into the board. That means it is now minus k cap. So it is minus k cap. So you can see now here minus into minus plus. Remaining is j cap cross k cap, which is now I cap. Okay, that means electrons are moving. Means on electrons, this magnetic force is now right side. So electrons will accumulate at this end. That means this end becomes negative and this end becomes positive. That means this end is now low potential and this end is now high potential, right? So like this, we can decide which end is at high potential and which end is at low potential. That means here we can write it is VA minus VB. That is equal to half B omega L square, right? If they ask like VB minus VA, then that becomes minus a half B omega L square. Okay, let us see now the next question. It is almost the same kind of question. You can see a rod of length L rotates with a small but a uniform angular velocity omega about its perpendicular bisector. A uniform magnetic field B exists parallel to the axis of rotation. The potential difference between the center of the rod and an end is. So almost same question. The only change is now axis of rotation is now it is a perpendicular bisector. That is the only change. See now where change comes in the calculation part. So earlier we have taken rotation about one end of the rod. Now rotation is now about this axis. I am taking once again axis is now say both the plane as xy plane and axis is now along that axis and rotation like this. So I am taking all are same and field is into the board. So that directly I can say from the previous question, see I have taken this as A, this as B. Let us take now this as C. Okay. Now see what is EMF induced. If you want to calculate now across AB means, see what I can write here. We have seen that A is high potential and B is low potential, right? Because this is what I have discussed in the previous question. Now coming to here about angular bisector. So this is L by 2 and this also L by 2. So I can write here VA minus VB, that is equal to, see in that calculation we got it is integration of B, L is dx, B, L, B value x omega, right? Now here what we have to do is change limits, that is 0 to L by 2. If I am taking this is origin 0 to L by 2, okay? That means see where change comes. I am taking B outside, omega outside, x dx, x square by 2. I am taking 2 outside. Remaining is now x square. So take limits. It is L by 2 whole square. So this is now L2 square 4, 4 to 6. It is 1 by 8. B omega L square. So VA minus VB, that is 1 by 8. B omega L square. So same as the previous problem, only changes. It is limits 0 to L by 2. And the last question I have taken 0 to L. In the same way, if you want to find EMF induced across AC, again same logic, VA minus VC, that is equal to 1 by 8 B omega L square, right? Because here again C becomes negative. You can see here electrons are moving towards right side. And here what happens? Here for electrons, velocity is now along positive y-axis. Here if I am taking electrons, velocity negative y-axis, right? So when I am taking force, that force will be now along negative x-axis. This is now negative. This also negative, right? That means if they ask what is the potential difference between the ends, that means VC minus VB or VB minus VC. Okay. And that will be equal to 0 because both are now at same potential. Or directly we can say from this two, VA minus VB, VA minus VC. That means VB equal to VC, right? That's why VC minus VB or VB minus VC equal to 0. Okay. So option is now, it is option D, right? Right. Let us see next one. And this question also, again, same kind of question. The only change is now limits. You can see AO, this is L, OC, 3L. That means we have to take limits 0 to 3L. Okay. To get VO minus VC. To get VO minus VA, we have to take limits 0 to L. Right? Let us see. Right. We can see diagram here. AOC. It is AOC. Given now AO length. AO equal to L. And next OC equal to 3L. Right? Again, rotation is now same. Field is now into the board. Right? Same as the previous problem. So then what happens is, you can see C becomes low potential negative because electrons will move towards C. In the same way, electrons will move towards C. So A and C are having negative potential and O will be at a high potential. So I am using the result of the previous problems, writing directly VO minus VC, that is equal to half B omega. In the place of L square, I am writing here 3L by, it is 3L whole square, half B omega L square. Now length of OC is 3L, right? So this is now 9 B omega L square by 2. This is now EMF induced across OC, right? Next, coming to across OA. Across OA, so I am writing VO minus VA equal to half B omega. Now length of OA, it is equal to L. It is now directly L square, right? Now see options. VA minus VO, VA minus VO, VO minus VA, half B omega L square. But he wants VA minus VO. That will be how much? Minus half B omega L square, negative. Okay. Next, VO minus VC. VO minus VC, that is 4.5 B omega L square. This is okay. Option B is correct. Next, VA minus VC. See, what is now VA minus VC? From this to see what I can write. Suppose this is 1. This is 2. We want to calculate VA minus VC. VA minus VC means what we can do is, it is equation 1 minus equation 2, right? See carefully, equation 1 minus equation 2. That implies, see what? This minus this. Then minus of minus becomes plus. So VA minus VC. V naught gets cancelled. So equation 1 minus equation 2. That is VA minus VC. 1 minus 2 means 4.5 minus half. It is a 4. So 4 B omega L square. Right? So VA minus VC. That means option C is correct. Option B is correct. Option C also correct. Next, VC minus VA. Already we got it, VA minus VC. Then VC minus VA means minus 4B omega L square. Is a pointer. If they ask like VC minus VA. But option D is VC minus VO, right? Already we have seen VO minus VC, right? That means this is not correct. Option 4 is not correct. So correct options are option B, VO minus VC. It is correct. And option C, VA minus VC, 4B omega L square, right? B and C. Okay. Let us see next one. Let's see the question given. The current generator shown in the figure sends a constant current I through the circuit. The wire AB has a length L and mass M and can slide on the smooth horizontal rails connected to IG. This is now current generated which sends constant current. The entire system lies in a vertical magnetic field B. Find the velocity of the wire as a function of time. Okay. Let us see how we solve this problem. First of all, make the given diagram. It is now current generator that is now sending constant current, right? And you can see the wire which can slide on these rails. It is now like this, given AB, and its length is now given as L. Mass M, length is L. And field is now into the board. Let me take this board plane as XY plane. Then field is along negative Z axis and direction of current it is given. Current is now I. Right. Now we have to find velocity of the wire as a function of time. Right. Now see how to start. You can see because of this current on this wire force acting. So I'm writing here F bar is equal to force acting on a current carrying element I into L bar cross B bar. I am focusing now direction part. So L bar, direction of L bar is now direction of current. Current is now A to B. A to B means it is along negative y-axis. So minus J cap. Okay. Coming to B bar. B bar is now into the board. That is now minus K cap. So minus J cap minus K cap. Minus into minus plus. Remaining is now J cap cross K cap. That is now I cap. That means force acting on that mobile wire. It is now right side, right? Force is now right side. And you can see this force is a constant force because I is a constant, L is a constant, B is a constant. Constant force acting, asking velocity as a function of time. So now what I'm doing is here. So we have learned that net impulse, or you can say impulse of net force. Impulse of net force is equal to change in momentum. This is what we have learned, right? You can see this force is now net force on that wire. So impulse of this force is equal to change in its momentum, right? So I'm taking now that force is now I into L into B, right? Into time, or you can say time interval. It is now T minus 0. In this time interval impulse, right? This is equal to change in momentum in that time interval. When time t equal to 0, this wire was at rest. Therefore, momentum was 0. At time t, its velocity is v. So it is now m into v, velocity, minus initial value c. Now directly from this, you can see v equal to, it is I L B into t upon m, right? So this is one way of solving the problem. Or if you want, you can solve the same problem by using kinematics. Here, force is a constant, right? Then I can write force by mass, that is acceleration, because F is now net force. That is now acceleration, which is equal to force is ILB upon M. This is acceleration, which is a constant. Initially, velocity is 0. So U value 0. Finally, velocity we have to calculate at time t. So I'm writing equation v equal to u plus at, right? U value 0, a value it is I L B upon m into t. Okay, so both are same. Either you can solve by using kinematics or you can solve by using net impulse is equal to change in momentum, right?